Australia's Precambrian areas in black contain a number of metal ores. Our short history and that of Britain and America shows us that no advanced nation can survive without an evolving and vibrant manufacturing industry based on scientific research, engineering and metallurgy. This video is dedicated to an Aussie hero that realised this, Essington Lewis, who helped save our country. The transition metals contain outer electron subshells that overlap. This produces a range of coloured compounds that artists love. They also have variable valencies, so that the one element can have reactive as well as stable ions. Melting points also vary widely. Tungsten was called Wolfram by the Germans and given the symbol W. Aussie deposits are found in King Island and Tasmania. Its hardness and high melting points allow tungsten carbide to survive white heat in light bulb filaments and to drill through steel. Mercury has a low melting point. The Romans called it hydrogyrum, meaning a liquid metal, so it has the symbol Hg. It attacks nerve cells. Mercuric oxide and mercury are banned in schools. A chemical plant in Japan released methyl mercury into the Minamata Bay. Several thousand people were horribly brain damaged after eating fish. Titanium is a non-magnetic lightweight metal with a high resistance to corrosion. It occurs naturally as titanium dioxide, a black mineral that we call rutile. It is heavier than sand, so you may have seen it concentrate on those parts of beaches where water continually flows backwards and forwards. Titanium dioxide in pure form is a white powder, and we are using it to replace poisonous lead in paints. We also use titanium metal in turbine blades. Chromium is a hard, high melting point metal that resists corrosion. It was named because its compounds have many colours, like these rare chromium minerals from Tasmania. Chromium metal's main use is in making stainless steel. 10 to 18% chromium prevents the iron from corrosion, so this saucepan is very easy to clean. Chromium-plated metals take a very high polish. Chromium chemicals that have the highest valence, chromium plus 6, are cancer-causing, particularly when mixed with acids. These chemicals are used in electroplating and in making copper's logs. Never burn copper's logs in wood heaters, or use them in barbecues, or the meat will be carcinogenic. Molybdenum is a high-strength, high-melting point metal used to make steel alloys with these tough qualities. Some bacteria use its compounds to fix nitrogen from the air to make protein. We have a number of molybdenite deposits in New South Wales associated with granites. Manganese is a grey hard brittle metal which oxidises like iron. It is an essential component in small quantities in a number of steels and even in smaller amounts in aluminium drinking cans. Australia has large deposits of its black oxide mineral on Groote Island in the Northern Territory. This supplies a quarter of the world's needs. Small amounts of the mineral are found in the Narrabeen Group rocks at Gary Beach, south of Sydney. They are called dendrites and look like plant fossils. Manganese compounds exhibit a number of colours depending on their valence. This makes their chemistry rather fun. Manganese dioxide is a catalyst for making oxygen from hydrogen peroxide. Then with precautions you can burn hot steel wool in the oxygen. Another interesting chemical is potassium permanganate or Condy's crystals, which is used to treat fungal infections and keep wounds sterile. It is another fun chemical, but be cautious. Iron is the most common element in the Earth by mass. The core of the Earth is believed to be made of iron-nickel alloys, similar in composition to that found in some meteorites. The crust of the Earth has less iron and it is usually combined with oxygen. Australia's hot Western Pilbara region contains old mountains containing the banded iron formations believed to have formed by the cyclic precipitation and rusting of iron in our early seas. The main iron ore is hematite, iron 3 oxide. Our mining industry is young, and we have had the foresight to partner with a number of countries to build the most efficient iron ore mining technologies on the planet, with huge trucks, ports and railway systems. The conversion of iron ore to iron requires a blast furnace. Black coking coal is cooked in coke ovens to form hard metallurgical coke, which is burned in the furnace as fuel using a blast of air. Iron ore is added together with limestone, which combines with sand to form molten slag that can be run off and used as road metal. Pure iron is quite soft and needs carbon and other alloying metals to make it hard. It also rusts very easily, and the rust expands and flakes off. Most metals do not do this. They are passivating and protect themselves with a thin layer of metal oxide. This is why metals such as nickel, chromium and manganese are added to prevent rusting. We've also developed a number of coatings for the steel, such as zinc aluminum and a variety of paints. Cobalt is one of the few metals capable of making permanent magnets. So it is alloyed with iron, aluminium and nickel and used in Alnico magnets. Historically, its compounds have been used to make colourful glasses and ceramic glazes. In schools, you may find cobalt chloride, that is pink when it contains water and blue when anhydrous. Another magnetic metal is nickel. It resists corrosion and is used with iron in stainless steel. Most Australian coins contain nickel alloyed with other metals. Australia has a number of nickel sulphide deposits near Kambalda in West Australia. Like cobalt, its compounds can be very colourful. As Asia industrialises, the metal copper faces a demand that can barely be met. Its main ore is chalcopyrite, copper iron sulphide. Australia still has high-grade copper mines. The world's big overseas copper mines contain only 1% copper and historically have largely ignored the proper treatment of the tailings that can be acidic. 60% of copper is used for electrical cabling, electric motors and electronics. 20% is used for water pipes. Some is used for roofing and guttering and preventing growths on ships. In air, copper slowly darkens with a coating of copper oxide. This can absorb carbon dioxide, forming green copper carbonate. Never put copper in contact with iron, otherwise corrosion occurs. Copper alloys are interesting. With zinc it forms brass. Alloying copper with iron kills nasty bacteria and viruses. There should be more use of this sort of metal in toilets, hospitals and homes for the elderly. Pretty blue copper sulphate is a fungicide. Please recycle your copper. Silver was called argentum by the Romans, hence its symbol Ag. It kills bacteria, so it has long been valued as cutlery and plates. Unfortunately, it tarnishes with hydrogen sulfide. It finds decreasing uses in X-ray plates, film and coins. It occurs in association with other metal sulfide minerals such as lead. Gold was called aurum by the Romans because it shone like the sun, hence its symbol Au. It does not tarnish and is rare. It sparked our first mineral and population boom in the 1850s. Australia's biggest gold superpit at Kalgoorlie is visible from space. Be careful of old gold furls. Poisonous liquid mercury and deadly cyanide were used to extract the gold from crushed rock. Use low-carat gold alloy in jewellery. It is harder wearing. Zinc Zn is a grey metal that finds uses in protecting iron from rusting. Australia mines its zinc sulphide ore, called sphalerite, in a number of locations. Our steel and manufacturing industries coat their products in zinc in a process called galvanising. The zinc blocks oxygen and, if scratched, oxidises to white zinc oxide preferentially. Another Aussie product is a coating of zinc and aluminium called zinc alume, used in metal roofing, guttering and water tanks. Zinc casings are still used in torch batteries, and white zinc oxide is an effective ultraviolet sunblock. To survive the challenges of our future, we need a balanced economy incorporating the full range of technologies, including metal manufacturing industries, using best environmental practice. To achieve this, we need a well-funded research base where scientists are no longer treated as casual workers. You might like to colour in these important elements on a periodic table and review in your mind some information about each.